Have you ever looked up at the night sky and wondered about the twinkling stars? Each one is a giant ball of burning gas, a cosmic engine that lights up the universe. Stars are the powerhouses of the cosmos, and their story is one of incredible transformations and explosive events. Stars are born in gigantic clouds of gas and dust called nebulae. Imagine these nebulae as stellar nurseries where baby stars are formed. Gravity pulls the gas and dust together, squeezing it tighter and tighter. This squeezing creates heat and pressure at the center of the collapsing cloud. As the temperature and pressure increase, something amazing happens. The core of the collapsing cloud becomes so hot that hydrogen atoms fuse together to form helium, releasing tremendous amounts of energy. This process, called nuclear fusion, is what makes a star shine. And just like that, a star is born. The newborn star illuminates the surrounding nebula, creating breathtaking views that telescopes can capture from Earth. These stellar nurseries are where the life cycle of stars begins, a cycle that involves growth, transformation, and ultimately, death. Once a star ignites, it enters a long, stable period called the main sequence. Our Sun, the star that provides light and warmth to Earth, is currently in its main sequence stage. During this stage, a star fuses hydrogen into helium in its core, releasing a constant stream of energy. This energy creates outward pressure that balances the inward pull of gravity, keeping the star stable. But stars, like humans, don't stay the same forever. As a star ages, it gradually uses up the hydrogen fuel in its core. Eventually, the core runs out of hydrogen and the star begins to change. For stars like our Sun, this means expanding into a red giant. Red giants are cooler than main sequence stars, but much larger. Smaller stars, after their red giant phase, gently shed their outer layers into space. This creates beautiful expanding clouds of gas called planetary nebulae. The remaining core of the star shrinks and cools down, becoming a white dwarf. White dwarfs are incredibly dense objects about the size of Earth, but with a mass similar to the Sun. Massive stars, much larger than our Sun, have a more dramatic fate. When a massive star runs out of fuel, its core collapses under its own gravity in a fraction of a second. This collapse triggers a shockwave that blasts the star's outer layers into space in a spectacular explosion called a supernova. Supernovae are some of the most energetic events in the universe, shining brighter than entire galaxies for a short time. The remnants of a supernova explosion depend on the mass of the original star. If the core is about 1.4 to 3 times the mass of our Sun, it collapses further, forming a neutron star. Neutron stars are incredibly dense objects, packing the mass of the Sun into a sphere only a few miles across. If the core is more than 3 times the mass of the Sun, its gravity becomes so strong that nothing, not even light, can escape its pull. This creates a black hole, a region of space-time, where gravity is so intense that it warps the fabric of the universe. Black holes are still a mystery to scientists, but they play a crucial role in the evolution of galaxies. Our Sun is a pretty average star, a yellow dwarf about halfway through its main sequence stage. But for us on Earth, it's anything but ordinary. The Sun is our source of light and warmth, the engine that drives our weather and climate. Without the Sun, life on Earth would not be possible. The Sun's energy comes from nuclear fusion happening in its core. Every second, the Sun converts about 600 million tons of hydrogen into helium, releasing a tremendous amount of energy in the process. This energy travels through space as light and heat, reaching Earth and sustaining life. Our Sun is just one of billions of stars in the Milky Way galaxy, but it holds a special place for us. It's the star that gave birth to our planet and allowed life to flourish. As we learn more about stars and the universe, we gain a deeper appreciation for the delicate balance of conditions that make life on Earth possible.